Thanks very much, Mr. Chairman. Ladies and gentlemen, it's really a great pleasure to be back in Melbourne this week and to be present at this fantastic event that you've put on. What I want to speak about today is the issue of vulnerable road users in Europe. I guess we've acknowledged, not only in this meeting, but in recent times, they really are one of the standout problems in terms of traffic safety. And an issue where maybe some of the safety strategy solutions are probably a little bit underdeveloped. And there are a number of studies going on in terms of what we do about vulnerable road users. And I thought I'd just touch on one of those studies today and say what might be possible from a technology point of view and where we are with that particular solution. To contextualize the road safety situation on a global level, there's some data that we saw recently looking at where different countries are in terms of their road tolls. And this is data, of course, from the World Health Organization Global Study Status Report of 2014, which shows where the countries that have performed really well are on a global level. And so you can do international comparisons and how countries have done since 1990. And somewhat surprisingly, I guess, Spain stands out as a nation where you've got the biggest improvements in safety since 1990, followed by Hungary, France, UK, etc. We know that Australia's made quite big progress, but there's still not as substantial as perhaps the best performing countries. And with apologies to people like Clay, Ken, and Ray, and other Americans who may be in the audience, progress in the US is not quite as substantial by comparison. Don't see this as a league table, by the way. There are obviously other countries that are not included here, but I just wanted to give you some idea, understanding of progression that's been made by a number of different countries. So it's really quite interesting to look at how the best performing countries have done in terms of reducing their road toll. For example, in Hungary, where reported fatalities fell from 2,432 to 605 in 2012, they've done a number of things. They have a really good national road safety program. They initiated a very sort of good speed camera enforcement program. And Hungary also had a very sort of aggressive zero tolerance to drink driving and witnessed fairly substantial increases in seatbelt wearing, which is now 87% for front seat occupants and something like 68% for rear seat. A remarkable improvement compared to where they were at the beginning of the study. Now, these are just headline reasons. I mean, obviously, there are other things that might have explained this particular reduction in fatalities, but you get the idea of what the headline issues are. In France, often regarded as a nation with fantastic wine and great cuisine, like Australia, really, it's really held up as one of the most successful countries in terms of road safety progress. And you have this issue where reported fatalities have dropped dramatically from something like 11,000 per annum in 1990 to 3,653 in 2012. A really, truly remarkable achievement, I'm sure you'd agree. And one of the main reasons for France's achievements is because they had a fairly aggressive speed management policy that they adopted in the year 2000, which was dominated by speed camera enforcement. And there are a number of academic studies that you can lay your fingers on, including the famous Carnis and Blaze study, which shows you really what you can do if you introduce a good level of speed enforcement, or sensible level for that matter. But also France has a much more developed, safer vehicle fleet, brimming with the latest safety technology, and the wearing rate for seatbelts has gone up as well, compared to when we started the study in 2000, at which point the seatbelt wearing was very low by comparison. I'm sure you're interested in Australia. This is Australian achievements since the year 1990. Reported fatalities fell from something like 2,331 in 1990 to 1,299 in 2012, a decrease of about 44%. And this despite an increase in journeys, in trips that are made, and also a rapid increase in the vehicle fleet, as I'm sure you can imagine. And the reason why Australia has achieved so much is because of intensive speed compliance measures, particularly effective on the urban roads, maybe less so on rural roads, but that's the way it is. But also highly targeted investment in road infrastructure, such as urban motorways, graduated licence and restrictions, and a particularly high seatbelt usage rate, probably one of the best in the world, if not the best, but far lower in fatal accidents. So usage ratio in fatal accidents is only about 28%, which concurs with the previous speaker. And speed management is quite good overall in Australia, but it's still thought to be a factor in around about a third of all fatal accidents. So when you look at the evidence, there's definitely some sort of commonality between the countries and what they need to do in order to reduce road accident fatalities, including the development of national road safety strategies specified usually in terms of absolute numbers, not necessarily linked to populations or kilometres driven, traffic speed management via sensible but effective enforcement, a safe vehicle fleet, hopefully with a large proportion of the cars being 4- or 5-star NCAP with the latest technology, good seatbelt wearing rates, and good data systems and data collection activities. This is really important, so you know where your priorities lie and what you need to do to get to the next level in terms of safety. So those of you who are familiar with the Sunflower study, which was completed around about 10 years ago now, will know that the best performing countries at the time of the study were Sweden, the UK, and the Netherlands, hence Sunflower. And at the time of reporting, the total risks in terms of deaths were more or less the lowest in the world, and they still are relatively low in these countries. And it's quite interesting to look at why their success was so high. In Sweden and the Netherlands, they have these achievements largely due to this sort of safe system approach to road safety, which we heard all about earlier. The safety plan of the UK was slightly different. We had the application of a good practice by local road safety or safety professionals with particular focus on improving the safety of specific target groups who were high-risk groups. But again, there was commonality as to how the Sunflower countries tackled the road safety, and by far the biggest contributor to the reduction was found to be passive safety measures and other technological systems in vehicles that we heard about in the previous presentation. Much more prevalent in these vehicles, which combined with seatbelt use, particularly in rear seating positions, and some active safety measures, including advanced brake and stability control, contributed to the excellent track safety records in the Sunflower countries. Road engineering was thought to be fairly much less of a contribution, relatively speaking, but vulnerable road user measures did seem to have some importance. And at the time, they included things like increased helmet use amongst cyclists and motorcyclists, reductions of speed, particularly in built-up areas, and alternative transportation of children to school. What we were doing, instead of allowing children to walk to school on their own, we were carting them off in buses to school. So you're reducing the exposure of children to vulnerable road user accidents. So who do we mean by when we say the vulnerable road users? Conventionally, we're talking about pedestrians, cyclists, powered two-wheelers, etc., because these are the road users who are vulnerable to injury in the event of an accident, since they are not enveloped in any way by a cocoon, as is the case with passenger car occupants. But you could also include in this group older drivers, people using mobility scooters, and children in cars. It depends really how you want to define them, but today I'm essentially referring to the first three I mentioned here. The problem is that data from Europe suggests that the VRUs now represent the most problematic group amongst the road users in Europe, with something like 68% of all fatalities in urban areas thought to be a vulnerable road user, with over 1/3 of these being pedestrians. Car occupants now only around about 29% of fatalities in urban areas. So there's been a really big shift in the accident constellation in recent times, because we've probably focused our attention, maybe quite rightly so, on preserving the safety of the car occupants, while not being quite so vigilant with regards to the other road users. Pedestrians, as I said, are by far the largest component of this group, followed by motorcyclists and cyclists. But cyclists are especially thought to be the most problematic group of the problematic group, since what we're doing is we're trying to encourage people to go out there and cycle, whilst at the same time injuring or killing several of those who do. And I know it's probably the same in Australia, because you only have to go on a journey down Beach Road to get an understanding of just how many people cycle out there in Melbourne. To illustrate the problem in even more detail, here's the trend for fatal accidents, within the EU for the different road user groups from 2002 to 2012. And what's clear, and this supports Anders' data, is the remarkable strides we've made in terms of fatality reduction across the EU, with fatalities decreasing from around about 50,000 to just under 30,000 during the period. And clearly, car occupants make up a large proportion of the reduction in fatalities, with numbers declining from 30,000 to 20,000, for obvious reasons that we saw previously. But you can't say the same for the vulnerable road users at all. Their numbers have certainly declined, but at a much slower rate compared to the other road user groups, and the problem group in particular. So what we've done here is to analyse just what might happen to road users in Europe if we continue at the current rate of progress. In other words, if we do nothing in terms of road safety countermeasures, this is where we're likely to be in the year 2030 using this exponential curve. And clearly you can see that passenger car occupant fatalities will reduce even further, just over around 5,000, we think, in Europe. A quite remarkable achievement, considering when you look back at the data. While VRU fatalities will decrease at a much lower level, such that the gap between the two, assuming you looked at the VRUs as a group collectively, will all but disappear, and you might get a situation where the VRU fatalities actually overtake the passenger car fatalities, and in fact that's probably likely. This probably illustrates the numbers somewhat more clearly for the VRUs. Their rates are falling, certainly, but if you combine the VRUs and consider them as one group, by 2030, according to our calculations, if you do nothing at all in terms of road safety interventions, what you will have is something like 5,500 VRU fatalities, which is pretty much the same as our predicted value for passenger car occupants. So currently, amongst other things, other studies of road safety in Europe, what we're doing is conducting a study at which the VRU is at the epicenter, trying to determine the likely effects of societal impacts of technology and selected what we call intelligent transport systems on the VRU accident problem, to provide some sort of recommendation as to the likely impact and uptake of ITS in terms of the systems that show the most promise in terms of proving the safety and mobility of VRUs. And also we want to provide evidence-based recommendations and practices on how the requirements of the vulnerable road users can perhaps be more fully integrated within the road transport system in terms of functionality and human-machine interface, and how we can sort of design those to meet the needs of the VRUs. Now, the project has several different facets, and in order to describe everything in detail will be rather cumbersome and somewhat overwhelming. So I'm simply going to describe to you some of the more simplistic aspects of the study so you get an understanding of where we are with some of the data analysis and what we can do from a technology point of view. First of all, just looking at pedestrian accidents and the scenarios in which pedestrian accidents are injured, you can see that overall they're most likely to occur when the pedestrian is crossing the road in a mid-block position, a location remote from a junction and remote from crossing facilities. So in terms of accident prevention through ITS, the times of junction and control systems that are becoming prevalent might not be so effective here, and maybe the solution needs to be predominantly vehicle-based. Junction-based solutions will still have a purpose here, though. In most cases, the accidents tend to occur on urban areas with lower speed limits, surprisingly, 50 kilometers per hour, during fine weather, when nobody's doing anything inherently silly. They tend to occur between 12 and 6 p.m., and perhaps some of these findings, you might argue, are counterintuitive. Looking at motorcycle accidents, this is the second most frequent injured VRU group after pedestrians, and a user group where maybe the technological solutions through ITS implementation are perhaps more achievable, certainly compared to pedestrians. Two common scenarios are quite evident for motorcycle and other powered two-wheeler users. The most common scenario is the powered two-wheeler being hit by a vehicle, mainly a passenger car, when they're both initially heading in the same direction, but the vehicle doesn't realize that the powered two-wheeler is present and subsequently turns across the path of the power two-wheeler. Another common scenario involves the vehicle pulling out from the intersection, particularly where they're required to give way into the path of the power two-wheeler. And this is, of course, a very obvious scenario, and there's all sorts of explanations that what's going on here, and it's the classic look but didn't see scenario, and I'll say a little bit more about this in a minute. Just some basic data about power two-wheeler accidents. You have this issue of males being more likely to be involved compared to females. Most accidents within an urban environment, mainly occurring on roads with low speed limits, 50 kilometers per hour or less, in fine and dry weather conditions during daylight hours. And not surprisingly, the majority occur in the summer months, which of course in Europe is slightly different to Australia. We're just emerging through the other side at the moment, fortunately. Finally, cyclist accidents, and here's where there's some commonality between the road user groups. So the majority of the cycling accidents in this analysis were found to occur at junctions, intersections, and again, one of the most common scenarios is exactly the same as what you have with motorcyclists, and one where the motorcyclist, or the vehicle pulls out into the path of the oncoming cyclist at a give way intersection. And again, it's the classic look but didn't see situation where clearly there's some sort of perceptual error going on. And one of the most plausible explanations for this is that the driver functions most of the time on some sort of autonomous level for much of the driving tasks, so you're not really sort of dead focused on what you're doing. And the automatic assumption for the driver in this scenario is that you expect to see another passenger car, not expect to see a cycle or a motorcyclist. And when you look for something that you don't expect to see, then you just pull out there, and that's when the accident occurs. And if this is indeed the case, it provides very clear evidence or support for some kind of technological intervention on behalf of the driver to overcome what is basically a simple perceptual error. As with motorcyclists, the other common scenario involves both the cyclists and the vehicle heading in the same direction, but with both the vehicle then turning into the path of the cyclist. And again, one of the explanations for this is the blind spot phenomenon, in that the motorcyclist can't be seen, or the cyclist can't be seen by the driver, simply because they're located in the blind spot, and therefore they're not visible when the vehicle starts to make its turn at the intersection. And again, some basic analysis about the time of day and the weather conditions, fairly intuitive and occurring in low-speed environments. So this is really a brief snapshot of the common accident types and scenarios involving vulnerable road users. And it clearly suggests that developing and even implementation of some available technology could and should play a role in preventing common accident scenarios involving the road user groups. Our first review of the technologies that are out there suggests that there are about 144 different systems, individual systems, that could be classified as a system that could play a role in prevention of vulnerable road user accidents. Those are the systems that are either near market or already on the market. And then we asked a number of experts to identify the key systems that could really have the best effect. We managed to bring that down to around 22 individual systems. And after further careful review, we came up with a list of 14 systems, 14 key systems or technologies that we think will be highly effective in reducing VRU accidents. The key system, or number one system, is the blind spot detection system through infrared sensing technology, able to provide some feedback to the driver regarding the presence of the cyclist or the motorcyclist, or even the pedestrian on the vehicle near side, and that you need to take some sort of accident avoidance maneuver. And this system is currently available either as an aftermarket device, or some manufacturers now put them as standard fitment on their vehicles. So there are currently trials going on within Europe to test these systems to see how effective they really are in terms of prevention of accidents. Another part of the project involves testing of some prototype technologies, such as the system here. And if time allows, I want to show just a brief video of a trial that we've been running over in Helmond in the Netherlands. And this is where you've got some sort of communication between the vehicle and the cycle with each other, so that the cyclist receives a warning of an impending collision at the intersection through some sort of haptic feedback mechanism on the handlebar, at the same time that the driver receives a warning within the vehicle. And this is also a trial we've been conducting in Spain, in which the crossing could be considered as a cooperative system, or cooperative to all road users, in that the system automatically recognises that the pedestrians are present and provides some information to the pedestrians that safe crossing is possible via a smartphone app. So you have information to the driver, so he's aware of the pedestrians crossing, and the crossing benefits also via the addition of additional illumination under nighttime conditions whenever the pedestrians are present and when they're detected by the system. So here, hopefully, if time allows, I'll just show this very brief video of the trials that have been running in Helmond.
Applications for intelligent transport systems will continue to assist in reducing the number of fatalities in Europe. Up until today, vulnerable road users have not benefited as much from ITS as vehicle users. The VRU-ITS research project, or VRUTS, focuses on ITS applications for vulnerable road users. The aim is to evaluate next-generation ITS applications and assess societal impacts. VRUTS also provides recommendations for policy and industrial development in order to further improve safety, mobility and comfort of vulnerable road users. In the Dutch pilot setup at TNO, an ITS intersection safety system for cyclists is evaluated. Cyclists are detected with radar by a roadside unit. The information is processed and transmitted to approaching vehicles, which automatically determine the risk of a possible collision. In case of a high risk, the driver hears a warning sound and the car automatically sends warning signals to the cyclist, who experiences vibrating handlebars. Subsequently, the car will automatically brake and slow down to a full stop if needed to prevent a possible accident. 14 cyclists and 23 car passengers participated in the pilot and filled in questionnaires before and after the tests to indicate their level of acceptance, perceived usefulness and trust in the system, as well as the perception of the impact of the system on future safety, mobility and comfort for users. Cyclists and car passengers were asked whether they felt safer on the road, as the system would provide them more information about road users in the vicinity. Both cyclists and car passengers believed that safety would be improved with the system, but they also cited that too much dependence could possibly introduce unsafe situations. Some other valuable research findings are: cyclists were also asked if they experienced added value of the system on their bike. Most of them agreed, or strongly agreed. Overall, we can conclude that all cyclists and car passengers awarded higher scores for usefulness and satisfaction after participating in the tests. The research findings and new insights of our successful pilot are vital for future improvements and ultimately the purchase and use of the system. Some of our research can be adapted and implemented by industry and government to improve user safety, mobility and comfort in daily traffic. The benefits are numerous.
Okay, so just to conclude this brief overview of what might be possible for VRU accidents, we've got data that clearly shows there's an issue here going on in Europe. Probably the highest priority challenge in terms of fatalities. Perhaps the biggest challenge involves what are the countermeasures for pedestrian accidents. Although even the other vulnerable road users, it's probably quite challenging as well. If we do nothing in terms of countermeasures or road safety interventions, data analysis suggests that this will be the target group in terms of fatalities, and they'll overtake car occupants. And we've seen that there are common scenarios in which we could act to introduce technology where we could reduce fatalities in different key situations. And yes, technology can help, and this video was just really to demonstrate that there are some technologies out there that will or have got capability to deliver results. But I think we're still a long way from being perfect in this regard. Whether they'll function effectively in all situations remains to be seen. And and we have to be sure that they don't introduce new problems into the road transport system that we can't yet predict, like people being too over-reliant on the system, etc. So while the technology is good and it's out there and we wholeheartedly support its implementation, we might just need to be a little bit cautious before we introduce such systems on a wholesale basis. Okay, thank you very much.